Hello guys, welcome to Scientia Academy. So in today's lecture we are going to discuss the topics based on the motion. That is the first part of the kinematics. As you know that kina is basically the motion and the matics. If you understand that is basically the study of. So the study of motion is the only thing that we'll be discussing in this chapter. So in this particular lecture we'll be discussing the question number 1 to question number 5. So there are 5 questions and we will be doing the solutions one by one, right? So today's lecture, I'm just requesting you guys to, when you get a question, right, you just read it, try to analyze it, then take 2 minutes of your time, after pausing the screen, 2 minutes of your time, and you do it yourself, right? You do your question, right? And you'll get an answer, right? So that answer, right, just keep and now you just resume playing the video and compare your answer with the answer that you could see in the screen. So I think in this way we can improve the way you think, the approaches, where you went wrong, right, rather than just copy pasting the thing. So yes, so let's go to the first question. So in the last video I think there were a few suggestions from I got few mails as well, and I got few suggestions about the question being very small, that they were not able to read it. So I just try to make the questions in one slide, and the next slide I will be discussing the answer. So yes, this is our question. A particle located at x is equal to 0 at time t is equal to 0, right? So the position and time is given, right? When the time is 0, position is also 0. Start moving along the positive x direction with a velocity v, right, along the positive x direction. Perfect. And that v which we have, it varies, uh, is equal to alpha times root of x, and the displacement of the particle varies with time. So here if you can see, the velocity over here is related to the displacement, right? Can I say that v is directly proportional to square root of x? From this equation, this is something which we really understand, which we can actually understand. So we have to find how this displacement is connected to the time. So let's do the question. So guys, you just pause the screen right now, take 2 minutes of your time, just do the question, and then come back to the screen, right? So we are gonna solve it right now. So yes, let's solve it. So in our question we know that v is given as alpha root x, right? We know that velocity is connected to displacement as dx by dt, right? So instead of v, can I substitute dx by dt? So dx by dt is equal to alpha root x. So as you know, t goes there, alpha if you take it here, I mean x you take it here. So you'll get dx by root x is equal to alpha dt. So, sorry. So this is what we get. So obviously when there is 1 by root x dx, you integrate it to find the total displacement from 0 to x. Dx by root x is equal to alpha time 0 to t dt, right? Is our first question, the answer to the first question. And so what is 1 by root x, which is actually 2 root x, differentiation from 0 to x by 1 is equal to alpha times integral dt is t, upper limit is t and lower limit is 0. So what we get is 2 root x is equal to alpha t, and from this if you square it, what you get is 4x square is equal to alpha square t square, and x square is equal to alpha square by 4 times t square. Alpha square by 4 is actually a constant, because alpha is constant, alpha square is constant, 4 is a constant. So, and I'm sorry, it's not x square, my mistake. So it's just x, yes. So here we are, yes. So x, I can write, I could write that x is equal to a constant times t squared, or x proportional to t squared. So we got the answer. The actual answer is option A, right? Okay guys, perfect. If you got the answer, it's good. If you do not, you didn't get the answer, it's still good. You just have to keep on trying, right? Now let's go for the second question. So our second question over here, when you see an object moving with a speed of 6.25 meter per second is decelerated at a rate given by. So dv by dt is minus 2.5 root v. Right, dv by dt, we know it's change in velocity by time taken, which is basically acceleration. And you can see here the negative sign, and the negative sign is there because it is, they have mentioned that it is a deceleration, and decelerated motion is negative. So where v is the instantaneous speed, the time taken by the object to come to rest would be, right? So yes, you guys pause the screen, take 2 minutes and try doing the question, right? Okay, so I hope you have finished doing the question. So let's do it together. So this is our question number 2. So guys, I'm just writing what is given in the question. dv by dt is equal to minus 2.5 times root v. As you know, dv, this is root v, v goes there, t goes there. So dv upon root v is equal to negative 2.5 times dt integrated, right, from 6.25 given in the question to 0. Listen, the speed is given as 6.25, right, was moving with. So when it comes to rest, so initially it's 6.25 and finally it should come to rest, so it's 0. V to the power of minus 1 by 2, in a root 1 by root v I can write as to v to the power of minus 1 by 2 is equal to negative 2.5 times integral 0 to t dt. So v to the power of plus 1 by 2 by 1 by 2 from 6.25 to 0 is equal to negative 2.5 times t minus 0, right? So guys, now listen. So what we get is minus 2 times 6.25, the whole to the power of 2 is equal to minus 2.5t. So you solve these equations and what you get is, you will get t as 2 seconds. T as 2 seconds. Clear? So we have an answer, and the correct answer over here is A. So for the first question and for the second question also, the option is A. Clear? Right, let's go for the third question, guys. Right. A car, this question, first of all, it's kind of related to the relative motion. This is related to the question, related to the content of relative motion. So guys, listen, let's discuss it. A car is standing 200 meter behind a bus. So in these kind of questions, keep in mind that a diagram is always helpful. You know, a diagram will help a lot in questions like this. Just keep this in mind whenever you're doing questions like this. So a diagram or a picture, right, it helps a lot. So the two start moving at the same instant but with different forward accelerations, right? The bus has acceleration of 2 meter per second square and the car has acceleration of 4 meter per second square. The car will catch up with the bus after a time of. So here what you have to find is time. So time is the thing we have to find. Time of what? The time the car will catch up with the bus, right? Let's you I as I mentioned, guys, please take 2 minutes, try to solve it, right? So I hope you have taken those 2 minutes, right, guys? Now listen, this is my car. It's 4 meter per second square. It's moving. This is my car, right? And at a distance of 200 meters apart, you can see the bus, which was moving with 2 meter per second square of different accelerations. This is my bus, right? Perfect. Is now from the given, the initial velocity of car and bus is 0, and acceleration of car is 4 meter per second square, and acceleration of the bus is 2 meter per second square, right? So what is the ACB, acceleration of car with respect to bus? Acceleration of car minus acceleration of bus, which is actually equal to 4 minus 2, you'll get just 2 meter per second square, right? So 2 meter per second square is our acceleration of car with respect to bus. We know that the position time relation. What is the position time relation? So if you ask like this, we will not be able to, answer. When I write the equation, you will be knowing that S is equal to ut plus half at square, right? So 200 is equal to, this is 0, initial velocity, half times, what is the relative velocity of car with respect to bus? It's the relative acceleration is 2 times t square. As we know that u is equal to 0, and acceleration of car to the b, this is 2 meters per second square. We just found out that. So we get t as 10 root 2 seconds. So what the answer? Our correct answer is option C. So we have an answer. So I hope you guys got the answer, right? Perfect. Guys, now let's go to the goods train accelerating uniformly. Yeah, a goods train accelerating uniformly on a straight railway track approaches an electric Ford standing on the side of the track. Its engine passes the pole with velocity u. Okay, and the guard's room passes with velocity v. The middle wagon of the train passes the pole with the velocity. Yeah, it's a good question. Let's see how it's done. Right. So you guys take 2 minutes time. Pause the screen. Just pause it. Take 2 minutes. Right. Okay. Now, yes, guys, can we start doing? Yeah, perfect. So the first thing which we have to do is you assume, or you just consider. Yeah. Let's consider that S be the distance. Let S be the distance between the two ends of the train, and also you just consider that A be the constant acceleration, right? So what is position velocity relation? V squared minus u squared is equal to 2as. From this, what is as? V squared minus u squared by 2. So let's say v be the velocity at the midpoint. So from this, what we understand? Vc square minus u square is equal to 2a times s by 2, right? Because it's a midpoint. So Vc square is equal to u squared plus as, and so Vc squared is equal to u squared plus as. Instead of as, I can write v squared minus u squared by 2. You solve it, you will get Vc as root of u squared plus v squared by 2. So what's our correct option? Our correct option is option D, right? You can see here u squared plus v squared by 2. That's our correct option. So I hope you guys got the answer. And let's move to question number 5, or our final question, right? Yes. A person climbs up a stalled escalator in 60 seconds. If standing on the same but escalator running with constant velocity, he takes 40 seconds. How much time is taken by the person to walk up the moving escalator? So this is the question. Guys, pause your screen, take 2 minutes, and solve the problems. Solve the problem, then come back. Yes, let's do the solution. So from what they have explained in the question, let's say the person's speed walking, it is only 1 by 60th of the escalator per second, right? Person speed walking is actually 1 by 60th of the escalator per second, or of the escalator in second. So when he is standing in the elevator without walking, the speed is 1 by 40th of the escalator per second. So when we walk with the escalator, the speed will get actually added. Am I right? The speed will get added, velocity concept. So the person's speed, so those who have confusion, if this is an escalator, let's say this is an escalator, and this escalator has a velocity e by g with respect to ground, right? Or let's say I'm going to write it as 2 meter per second. And if a person is walking here, and this velocity of man with respect to the escalator is, let's say, 5 meter per second, then what is the velocity of this man with respect to ground? That is man with respect to the escalator plus velocity of escalator with respect to ground, which is 5 plus 2 is equal to 7 meter per second. So this is the concept behind it, those who do not understand it. So walking with escalators, obviously the speed get added, right? So the person's speed will be 1 by 60th. I mean 1 by 60 plus 1 by 40 is 15 by 120 times the escalator speed per second, right? So if we consider the time to go up the escalator, comma t is 120 upon 5, which is basically 24 seconds. So we have an answer, and the correct answer is option C, right? So I believe that you guys understand the entire content perfectly and completely. So if you have any kind of doubts in the questions which we have discussed right now, please comment below, share with your friends, and uh, next topic that we are going to discuss is going to be kinematics 2. So please stay tuned. So please stay tuned, guys. Thank you so much for